When a load acts along the axis of an object towards the ends, tensile stress is created in the object. An object subjected to tensile stress will increase in length because the distance between the atoms in the object increases. A copper rod subjected to tensile stress increases in length because the distance between the atoms in the copper crystals increased. When a load acts along the axis of an object towards the middle, it creates compressive stress. An object subjected to compressive stress will decrease in length because the atoms in the object are pushed closer together. A copper rod subjected to compressive stress decreases in length because the distance between the atoms in the copper crystals decrease. For the same object, if it is first subjected to tensile stress, then subjected to the same value of compressive stress, the change in length in each case will be identical. In other words, the tensile stress will increase an object's length a certain amount, while the same compressive stress will shorten the object's length the same amount. The amount that tensile or compressive stress changes the length of an object depends on three factors. Factor 1. The original length of the object. The change in length of an object subjected to the same value of tensile or compressive stress is directly proportional to the object's original length. Which is to say, if we double the original length of the object, the change in length will increase by a factor of 2 for the same stress. If we divide the change in length of the object by its original length, we get the change in length per every meter length of the object. This relationship is called the strain in the material. So the formula for strain equals the change in length divided by the original length. And because strain is a ratio, the units cancel. Factor 2. The amount of stress in the object. For any given object, the strain is directly proportional to the stress. So if we double the stress on an object, the strain doubles. This property is called Hooke's law. Since strain is directly proportional to stress, and strain equals the change in length divided by the original length, we can say that the change in length of an object under tensile or compressive stress is also directly proportional to stress. Double the stress and we double the change in length of the object. The type of material. The magnitude of the change in length of the material, when stressed, depends on the composition of the material. This factor is constant for any given material and is called the modulus of elasticity, or E, and is measured in the same units as stress. For example, the value of E for steel is 200 gigapascals. Combining the above three factors gives us the equation strain equals stress divided by E. Rearranging the above formula, we see that if we divide the strain into the stress for any given set of values, we get the constant E for the material. To the right we see a plot of stress divided by strain for steel, which gives us an E value of 200 GPa. If we divide stress by E, we get the strain in the material. Example, a steel rod has a stress of 100 MPa. What is the strain in the rod? Strain equals stress divided by E. Strain equals 100 MPa divided by 200 GPa. Strain equals 100 MPa divided by 200,000 MPa. Strain equals 0.0005. As long as the material being stressed is nowhere near the breaking point, the value of the modulus of elasticity remains constant and the material will be elastic, which means the material will return to its original length once the stress is removed. If the stress on the material is increased so the material is close to failing, then the strain is no longer proportional to the stress, and the change in length of the material will increase exponentially with an increase in stress. The object will also lose its elasticity and will retain its new length once the stress is removed. The value of stress that causes an object to lose its elasticity is called the elastic limit. Solving stress and strain problems may seem complex, but may be just a process of working through several simple steps. Sometimes it helps to write down all the stress equations, the information you are given, and the variable you are seeking. You can then decide on the steps you have to take in logical order and arrive at the final solution. The stress equations are stress equals load divided by area, strain equals stress times E, strain equals the change in length divided by the original length. For tensile stress, the new length equals the original length plus the change in length. And for compressive stress, the new length equals the original length minus the change in length. Example, a 30-meter steel cable has a weight of 50 kilonewtons suspended from it. The stressed area is 0.000314 meters squared. What is the new length of the cable under stress? So the first thing we have to do is define the process. We will write down all the information we are given or know and what we are looking for. So we know the original length, the load, the stressed area, E for steel, and we are looking for the new length. Second, we write down the stress formulas, highlighting the knowns and what we are looking for. Then we look for the formula that has the unknown in it. And that's formula 4, which is the new length, and that equals the original length plus the change in length. Since we have the original length but don't have the change in length, we look for a formula with the change of length in it. That's formula 3, which says strain equals the change in length divided by the original length. We have the original length, but we don't have strain, so we have to look for a formula with strain in it. That's formula 2. Strain equals stress divided by E. We have the value of E, but we don't have stress, so we have to look for a formula with stress in it, and that's formula 1. Stress equals load divided by area. Since we know both the load and the area, we can first find the stress, then we use the stress in formula 2 to find the strain. We use the strain in formula 3 to find the change in length, and use the change in length in formula 4 to find the new length. So if we do it in those steps, this is the way we work through it. This is the math, and you should get an answer of a new length of 30.024 meters.